All right, hey again, Honors Chemistry. I just want to set you up for 11, and then we're going to do 12. So number 11, the question asks, what volume of sodium sulfate solution must she add to her flask so she has no excess reactant? The question's asking for volume, so you're going to have to do moles divided by molarity, and that's going to be equal to volume. And you are given enough information. You're given a molarity of the sodium sulfate, and it's asking for the volume of the sodium sulfate. So eventually, from the BCA table, you should be able to get moles of sodium sulfate divided by the molarity, and that's going to be the volume in liters. Okay? And then for number 12, I'm going to jump us down now. It says aqueous calcium chloride reacts with aqueous sodium carbonate. So I'm going to start writing it. Calcium is Ca2 plus. Chloride is Cl minus 1. Crisscross method, CaCl2 aqueous. Sodium carbonate, Na plus 1. Carbonate is CO3 2 minus. Crisscross method is Na2 CO3 aqueous. To form calcium carbonate, CaCO3 solid, and aqueous sodium chloride, AQ. Okay? Determine the volume of 2 molar calcium chloride. So again, determine the volume of 2 molar calcium chloride solution that would be needed to exactly react with 0.065 liters of 1.5 molar sodium carbonate. And then let's just make sure this is balanced. There's 2 Cl's and 2 NA's. Got to put a 2 here. Done. 1 Ca, 1 Ca, 1 CO3, 1 CO3, done. All right, so now let's see what's given to me. I have 0.065 liters of 1.5 molar Na2CO3. So I'll do my BCA table, and I could use my favorite equation. Okay, I was given 0.065 liters of 1.5 molar Na2CO3. If I multiply liters times molarity, remember, molarity times volume in liters is equal to moles, and that's what I could put in a BCA table. So 0.0650 times 1.5, I get 0.0975. 0.0975 moles of Na2CO3. I'm going to shove that right here in the BCA table. Okay, and the question asks about calcium chloride. So the question doesn't really ask about the products, but I had to write the products so I could balance it, and now I don't care about them. The question asks about the relationship between calcium chloride and sodium carbonate. Luckily, this is a 1-to-1 mole ratio, right? It's balanced. So if I wanted to, I could do minus 975 moles. I get 0. This is a 1-to-1 ratio. So I should also use 0.0975 moles, 0.097 moles of calcium chloride. And it's okay that they're both 0. It says needed to exactly react, so I don't have anything in excess. So this means I have 0.097 moles of calcium chloride that's needed. And it says determine the volume of 2 molar calcium chloride. So I have a 2 molar calcium chloride. I have a moles and I have a molarity. And like I mentioned up here in number 11, what you're going to do, moles divided by molarity is equal to volume. So moles divided by molarity is equal to volume in liters. So what I'll do is I'll take my moles, 0.0975 moles, and I divide it by my molarity, which is 2. And I should get my volume in liters. So I already have my 0.0975 stuck in the calculator from before. And so what I'm going to do is I'm going to divide that by 2. Oops, sorry. Never mind. Got messed up. 0.0975 divided by 2. And I get 0.04875. So I'll do 488 liters. Which, if I multiply by 1,000, it'll be 48.8 milliliters. Okay? So my answer should be 0.0488 liters, which is the same thing as 48.8 milliliters. And that's just me rounding. All right, so how did I do that? Quick recap, and then I'll be done. I had a molarity and volume of my sodium carbonate. I knew it was a 1-to-1 mole ratio, so whatever moles of sodium carbonate I had, it was equal to my moles of calcium chloride. And so I wrote that down. And then they gave me 2 molar calcium chloride. So I have 2 molar calcium chloride. And the question's asking about determine the volume. So using that new equation that we learned, molarity is equal to moles over liters. If I rearrange that, moles over molarity is equal to volume in liters. I take my moles, I divide it by molarity, boom, I get my volume in liters. Alrighty, so I am done. I have made several videos on using molarity in the equation and helped you out a little bit. Hopefully you could use these to guide you in answering questions 11, and then go on and answer questions 13 and 14. And then 14, I put a star here. It's a limiting reactant and solution stoichiometry. So this is going to be the most challenging problem. What I would say for 13 and 14 is set yourself up, write and balance the chemical equation, and then see if I have molarity and volume and how I can get my value of moles in there somewhere. Alrighty, let me know if you have any other questions or concerns. Honors Chemistry. Hopefully this video was helpful.